Welcome to True Projects. In this video, we are going to explain about project titled Criminal Identification using ML and Face Recognition Techniques. The introduction of the project discussed the application of machine learning and face recognition method in criminal identification. The author utilizes the pre-trained model to detect the face and extract the relevant features from the image of criminals. These extracted features are employed to train the support vector machine algorithm for the classification of individuals as either criminals or non-criminals. The objective is to enhance the accuracy and effectiveness of the criminal identification procedures used by law enforcement agencies. The primary aim of this project is to create an advanced criminal identification system by leveraging the machine learning and face recognition technique. The specific objective including the utilization of MTCNN pre-trained model to detect the face in criminal images, extracting the facial features known as embeddings using the FaceNet model, and training an SPM algorithm with these features to classify the individuals as criminals or non-criminals. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that are developed to build this website. The first module is upload the criminal dataset. In this module, the user will upload the criminal dataset to the application. The dataset will be loaded along with the MTCNN, that is multitask cascaded convolution neural network, and FastNet models, which are used for face detection and feature extraction. And the second module is pre-processed dataset. This module involves reading each image from the dataset. The faces in the images will be detected using the MTCNN model and the features will be extracted using the FaceNet model. The extracted face values will be normalized and the dataset will be split into training and testing part. Third module is Train SVM using the MTCNN and FaceNet features. In this module, the SVM algorithm will be trained using the faces and extracted features from the FaceNet model. The SVM model will be trained using the 80% of dataset, and then the trained model will be applied to the remaining 20% of the images to calculate the prediction accuracy. And the fourth module is Train the HOG SVM. In this module, the SVM is trained with the HOG technique and the model will be trained with of 80% of dataset, and the trained model will be applied to the remaining 20% of the images to calculate the prediction accuracy. And the trained HOG KNN. Here the HOG is applied with the K nearest neighbor algorithm to the extracted features from the FaceNet model. This model will be trained using the 80% dataset, and the trained model will be applied to the remaining 20% of the images to calculate the prediction accuracy. And the final module is of criminal identification. In this module, the user can upload a test image to the application. The SVM model will predict whether the person in the image matches any existing criminal records. The matching percentage will be calculated, and if there is no match, alert message will be displayed. If an image matches with an existing criminal, the matching percentage will be displayed. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The dataset folder consisting of dataset of different persons, images, and the model folder. Here it consisting of .hy files which are loaded into the project code during the runtime to utilize the trained model for various tasks such as making predictions on the new data or performing the specific operation. And the test images consisting of different images, and the criminal identification and training code or the Python files, and this is a run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Criminal Dataset. By this, we are going to import the dataset folder and click on Select Folder button. Here, the dataset is loaded with the criminal list found in the dataset is of these names, and the empty CNN and FaceNet models are also loaded. And now click on Pre-Process Dataset button to process all the images and split them into the training and testing part. Here the total images found in the dataset is of 59 and the 80% of dataset are used for the training part, that is of 47, and of 20% of dataset images are used to testing part, and it is 12. And then click on Train SVM using empty CNN and FaceNet features. Here in this screen, the x-axis represents the predicted labels and the y-axis represents the true labels, and all different color boxes in the diagonal represents the correct prediction count, and the blue color boxes contain incorrect prediction count, which is of 1. And SVM is accurate in criminal classification. Now close this graph. And SVM gives an accuracy of 99%, precision of 97, recall of 94 and F-score of 96%. And then click on Train HOG SVM. And this graph, x-axis represents the SVM metrics and y-axis represents the values, which is closer to 1. Now close this graph and then click on. Here HOG SVM gives accuracy of 13.6 and HOG SVM gives the precision of 8.1 and recall of 5.1 and F-score of 6.1. And then click on Train HOG KNN. By this, the KNN model is generated, where the x-axis represents the true class and y-axis represents of the predicted class. And close this confusion matrix. And then KNN gives accuracy of 39.6, precision of 51.5, recall of 43.0, F-score of 39.7. And then click on Criminal Identification button. By this, we move on to the Test Images folder. Select any one of the image from this dataset, and I am selecting the first image and click on Open button. Here, it detected as Osama with a 58% rate, and close, and it is matched with this image, and then close this image. In this way, we can identify the criminal by using the ML and face recognition technique. In conclusion, the developed criminal identification system using the machine learning and face recognition technique has shown the promising results. By leveraging the pre-trained model MTCNN for the face detection and FaceNet and for feature extraction, coupled with the SPM classifier, accurate classification of criminal and normal individuals was achieved. The system performance was evaluated through the accuracy metrics, demonstrating the potential for criminal identification application.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.